Hello students, week 15 physics for grade 11, chapter 34 lesson number 9, the speed of electrons in a circuit, textbook page 691 and 692. At the end of the lesson, you will be able to describe the drift speed of conduction electrons in a current carrying wire. When you flip on the light switch on your wall and the circuit is completed, the light bulbs appears to glow immediately. Energy is transported through the connecting wires at nearly the speed of light. The electrons that make up the current, however, do not move at this high speed. So you have noticed when you switch on, immediately the bulbs light. So the light, or you can say energy, is transported through the connecting wires at nearly the speed of light. But actually electrons do not move at this high speed. The electrons inside a metal wire have an average speed of a few million kilometers per hour due to their thermal motion. This does not produce a current because the motion is random. There is no net flow in any one direction. When a battery or generator is connected, an electric field is established inside the wire. A pulsating electric field can travel through a circuit at nearly the speed of light. The electrons continue their random motions in all directions while simultaneously being nudged along the wire by the electric field. So the conducting wire acts as a pipe for electric field lines. Inside the wire, the electric field is directed along the wire. So we use conducting wires, they act as a pipe for electric field lines. You can see this figure. The electric field lines between the terminals of a battery are directed through a conductor which joins the terminals. You can see the battery without the conductor there. Look at the electric field lines, and then whenever you connect the two terminals with the wire acts like a pipe. Conduction electrons are accelerated by the field. Before the electrons gain appreciable speed, they bump into metallic ions and transfer some of their kinetic energy. Collisions interrupt the motion of the electrons, so their actual drift speed or net speed through the wire is extremely low. In the electric system of an automobile, electrons have a net average drift speed of about 0.01 centimeter per second, so this is very low. Now the solid lines depict, look at the figure here. In this figure, you can see the solid line and dashed line. So the solid lines depict a random path of an electron bouncing off atoms in a conductor. The dashed lines show an exaggerated view of how this path changes when an electric field is applied. The electron drifts toward the right with an average speed less than a snail's pace. So the movement is actually very low. If you compare with the speed of electron and speed of snail can actually move faster than electron. Here, what is the sense? You have to think that the drift speed toward the right with an average speed is always less. In an AC circuit, the conduction electrons don't make any net progress in any direction. In a single cycle, they drift a tiny fraction of a centimeter in one direction and then the same distance in the opposite direction. So they move one direction and then the opposite direction. So they oscillate rhythmically about relatively fixed positions. On a conventional telephone, it is the pattern of oscillating motion that is carried at nearly the speed of light. The electrons in the wires vibrate to the rhythm of the traveling pattern. So there is an oscillation. So that's what the movement becomes low. Now there is a question: why is the drift speed of electrons in a current carrying wire extremely low? Try to find the answer. See you and thank you.